Hello all, new chapter 5 notebook here. We are going to cover 5.1 polynomial functions today. Your objective is that you guys will be able to classify polynomials and can graph polynomial functions and describe end behavior. So the first step here is just to realize what the degree is talking about, what even is a degree of a polynomial, and can we order them from greatest to smallest. So the degree of a polynomial is simply the exponent, what the exponent is. So if we look here at this 5x example, that's really just an exponent of 1. So if we order these from greatest to smallest degree, we bring the whole term here, 4x cubed, and then 3x squared, and 5x, and negative 2. Now this negative 2 is really like x to the 0, but anything to the 0 power is just 1. So we just write negative 2. That's called a constant by itself. So now, the standard form of a polynomial function arranges the terms by degree in descending order. So if we go ahead and switch these out to addition symbols, we have a polynomial in standard form because the degrees are in descending order. So the polynomial classifications. So we have degree of 0. You'll notice here we're looking at the example here. We have degree 0. So the name of this is actually constant. I said that just a minute ago. A constant is just a number term by itself. And the number of terms here, there is only one. It's just the number 5. There's one term. And this is called a monomial. If you recall about prefixes, the prefix mono means 1, so we have a monomial. Now, our greatest degree of this polynomial example is 1. Recall, we're only talking about the greatest degree. And this is a linear. This would be a straight line. We rise to our y-intercept, and then we do our slope, 1 over 1. There are 2 terms here, x and 4. So this is called a binomial. The next one, we have a degree of 2. This is called a quadratic. We just finished up doing a bunch of stuff with quadratic equations. There are U-shapes. There's only one term here once again. So this is also called a monomial. This next one, our greatest degree is 3. So we have a cubic. You think the cubed root, or like a cube. Find the volume, you take the 3 sides multiplied. Cubic is 3. There are also 3 terms here, which makes this called a trinomial. The next one has a greatest degree of 4. This is called a quartic. You could think like quarter, quartic, just a quart. There are 2 terms here, so we're back to binomial. And then lastly, we have a 5th degree. This is called a quintic. Maybe you've heard of quintuplets. That's when 5 babies are born at the same time. There are 4 terms here, and we actually don't have a fancy prefix for this. This is just a polynomial of 4 terms. Hopefully that's easy enough. We're just classifying. We're going to do that here on this next 2 examples. Write each polynomial in standard form, and then write what is the classification by degree and number examples. I do want to point out, quartic is not always a binomial. That is just this specific example in the middle. So the first thing we need to do is write this in standard form. Remember, standard form is degrees from least to greatest. greatest to least, biggest to smallest. 5x to the fourth, keep the signs in front, plus 3x cubed minus x. That is our standard form, greatest to least degree. And then our biggest degree is 4, so it is a quartic. And there are 3 terms, so it is a trinomial. All right, this next one, I do want you to be careful on ones like these. You might need to combine like terms. That would change how many terms when we name it there are. So make sure if you can combine like terms, do it. So we have negative 4x to the fifth plus 2x squared plus 3. Name it by its degree as well as number of terms. So we have highest degree, quintic. So our leading term has a quintic. And there are 3 terms once again, so this is also a trinomial. All right, hopefully that wasn't too bad. Now you just heard me say leading term. The leading term is the term with the greatest degree. If we have it in standard form, it's the one furthest to the left. So the degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points or changes of directions. So if we were talking about a quadratic, if it was a happy quadratic, it would be going down and then change direction and go upwards. So that would be considered one change of direction where it switches the way it goes. It also affects the end behavior or the directions of the graph to the far left and to the far right. So for the end behavior of the polynomial function, we're only looking at that first term. So for example, the 5x to the fourth. 5 would be our a term, and the degree 4 would be our n term. So if we look, is a positive or negative? Well, a is positive 5, so we're in this row. And if n is even versus odd, even, we're in this column, so where they meet up. Our picture is going to be an up graph, so there's a good chance, so both arrows point up, that it'll look something like that. Because both arrows are pointing upwards, the left one and the right one, and we'll get to changes in directions in a minute. So we do have some more examples. We are going to describe the end behavior. First of all, check to make sure they are in standard form. Well, we have the third degree and then the first degree, so standard form, and then we have fourth, third, second, constant, so we are good to go here. We can go ahead and just look at our leading term. So, positive, negative for the a term, 4 is positive, even, odd for the n term, the degree, this time it's odd. So we have a graph that has arrow down and up. So we have a down arrow on the left side and up arrow on the right side, and then we fill in what happens between. It might be something like that. I'll show you in just a second when that might not happen though. All right, and then this next problem 2, is -2 positive or negative? Well, it's negative. And then our degree is even. So this is going to be a down graph. It could look something like this. Okay? Now, how do I know how many changes of directions there are? How many turning points? Because I put 2 in this graph, but I put 3 in this one. Why? Well, it says, in general, the graph of a polynomial function of degree n, that is if our degree, our exponent, is bigger than 1 or equal to 1, has at most n minus 1 turning points. So, if it has its maximum number of turning points, an odd degree function has an even number of turning points, and an even degree function has an odd number of turning points. So if we look at these examples up here, this had an odd degree, so I put 2 turning points in it. It went from going upwards to going downwards to going back up again. And if I look at this one, I knew it was a down, down. I had n minus 1, so 3 changes of directions. Goes from up to down to up to down, changes directions 3 times. So what is the maximum number of turning points? The max number here is just the degree minus 1. So 2, same thing here. Make sure, put this in standard form. Negative x to the 4th plus 3x. So we're actually looking at the 4. The max number is 3 turning points. Now, the maximum number is helpful, but is not actually necessarily always true. If we take a look, I'm going to flip over to Desmos here, and we're going to actually graph these to show you what they look like. So, although 1/2 x cubed could have 2 turning points, if we take a look at it, it actually has no turning points. It goes from going positive, 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 and stays positive the whole time. There are actually 0 turning points on this one. So there is a maximum number of 2 turning points, but there are no turning points. If we add a second picture for the other one, we have 3x minus x to the 4th. This one actually has only 1 turning point. It switches from going positive, 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 positive to negative. So there is only 1 turning point here. So it's not necessarily the max amount, but the max amount tells us the upper bound, you could say. So we'll say real number of turning points or changes of direction is 0 on this one, and then the real number of turning points here is 1. Okay? And that's all I have for you today. Have a great day.